Hello friends. If you recollect, our introduction video gave us some insights into solids that we see in our daily lives and which are actually a combination of basic solids such as a sphere, a cone, a cuboid and a cylinder. Now before we understand how to find the surface area and volume of these real life solids, we should understand how to find the surface area and volume of these basic solids. So let us recollect how we can find the surface area and volume of these solids. Let's start with the most intuitive solid, a cuboid. As you know, a cuboid is a three-dimensional solid with 6 faces, and each of these 6 faces is a rectangle. Now the best example for a cuboid could be this very room that we are standing in, or even a gift box, something like this. Every solid that we know has some basic dimensions using which we can actually construct the solid. Now for a rectangle, length and breadth are the basic dimensions for a rectangle. So for a cuboid, you need length and then you need breadth and then you need height to actually construct it. So length, breadth and height are the basic dimensions for a cuboid. Now the total surface area of a cuboid is nothing but the sum of the areas of each of the 6 faces, right? And the area of each face in a cuboid is nothing but the length into breadth of that particular face. So therefore, the total surface area of a cuboid is 2 into LB plus LH plus BH, where L is the length, B is the breadth and H is the height of this cuboid. Now, for finding the volume of a cuboid, we need some skills in actually visualizing this solid. Now consider a playing card that has almost negligible thickness. Now if I keep stacking playing cards one on top of the other, I result in a deck of playing cards that resembles a cuboid and actually has a height h, which is not negligible but a finite quantity, right? So in the same fashion, we can say that a cuboid is infinite thin rectangular sheets stacked one on top of the other. So the volume of a cuboid is nothing but the area of each sheet multiplied with the height h, right? Because area is nothing but length into breadth, so volume has to be area into the height, right? So the volume of this cuboid is LB into h, that is LBH, where L is the length, B is the breadth and h is the height of this cuboid. Now let's move to the next solid, a cylinder. Now how do we understand a cylinder? A cylinder is a result of stacking circular cards one on top of the other. Now remember that we have stacked rectangular cards in the case of a cuboid. Now here we are stacking circular cards to result in a cylinder. Now that means if you cut a cylinder horizontally, then the cross section should always be a circle. Now also note that we have stacked the circular cards in a perpendicular fashion. Now you can also stack them oblique fashion, but we will only consider right circular solids where the direction of stacking is always perpendicular to the base of the solid. Now what do you think are the basic dimensions for a cylinder? Now the basic dimensions for a cylinder are the radius of the base and the height of the cylinder. Now why there are only 2 basic dimensions for the cylinder? Now the reason is because with the radius of the base I can construct the circle and with the height I can construct the cylinder from the base. So therefore radius of the base and height of the cylinder are the 2 basic dimensions for the solid, and therefore the volume of the solid is nothing but the area of the circular base into the height of the solid, and the area of the circular base is nothing but pi r square and the height is nothing but h. So therefore the volume of the cylinder is equal to pi r square into h, that is pi r square h. Now for the surface area of a cylinder, there are 3 parts to it. There is a curved surface which has some area, and there are 2 flat surfaces on either ends whose area is nothing but pi r square each. Now the question is, how do we find the area of this curved surface? Well, for that we can do something very interesting. We can just cut open a cylinder across its height and just open it up as a 2-dimensional sheet. Then you will notice that you get a rectangular sheet, right? Now what is the height or the breadth of this rectangular sheet? It is nothing but the height of the cylinder, right? Because we just opened the cylinder in this fashion, so the height should be h. But what is the length of this rectangle? It should be the outline of the circular base, or rather the circumference of the circular base, right? because we just opened up the circumference as a straight line. So the length of this rectangle has to be 2 pi r and the height is h. So the area of this rectangular sheet is 2 pi r into h, that is 2 pi r h. Now this is nothing but the curved surface of the cylinder. So therefore, the curved surface of a cylinder is 2 pi r h, where r is the radius of the base and h is the height. And the total surface of the cylinder is 2 pi r h plus pi r square plus pi r square, that is 2 pi r h plus 2 pi r square. So friends, we have revised the formulae for surface area and volume of a cuboid and a cylinder. So in our next session, we will revise the formulae for surface area and volume of a cone and a sphere. But before that, let us quickly summarize our learnings. If the length, breadth and height of a cuboid are given as L, B and H respectively, then the total surface area of the cuboid is given by 2 into LB plus BH plus LH, and the volume is given by LBH. If the radius of the base of a cylinder and its height are given as R and H respectively, then its curved surface area is given by 2 pi RH, its total surface area is given by 2 pi RH plus 2 pi R square, and its volume is given by pi R square H.